Yeah, so hi everyone, I'm Riya, and today I'm going to be presenting my research on the link between cigarette smoking and schizophrenia. So right now we know that individuals with schizophrenia actually tend to smoke at much higher rates than the general population, but recent studies actually suggest that smoking might not just be a coping mechanism, but also be a cause of schizophrenia. And so my study analyzes fMRI scans to investigate this possible connection. Oh, it's like the slide before the introduction slide. Okay, yeah, I was just gonna introduce myself, but my mentor was Samira Sankara. I'm really, really thankful that she was able to guide me. And I'm from the Bay Area, and like the reason why I chose this topic was because I'm really interested in neuroscience. I plan to major in it in college. So it's something that's always been super interesting to me to see how the brain works. And yeah, so going on table of contents, I'll just be kind of going in 8 sections. So I'll start off with the introduction that I just did. I'll talk about objectives of my research, a little background, methods, and materials. Next slide, please. And then I'll do a results overview, key findings, analysis, conclusions, and more. So, schizophrenia is a serious mental disorder that affects perception, thinking, and emotions. It has been well documented that people with schizophrenia smoke at a much higher rate than the general population. However, the question still remains, does smoking simply relieve symptoms, or does it play a role in the onset of the disorder? Since we know that nicotine affects dopamine pathways, which is already altered in schizophrenia, the study aims to examine how smoking may influence brain connectivity. So my research specifically focuses on how schizophrenia or how cigarette smoking affects brain connectivity over time, specifically in the dorsolateral prefrontal cortex. This brain region is crucial for reasoning, decision making, and impulse control, and is often impaired in schizophrenia. My hypothesis is that smoking accelerates the loss of brain connectivity in this region, increasing schizophrenia risk. So, as what we know right now is that nicotine interacts with the brain's dopamine system, which is already dysregulated in schizophrenia. As you can see in the image, it kind of just shows that when nicotine enters the brain, it stimulates the receptors, which causes the dopamine release. And we know that there is some sort of change that happens with the dopamine levels in your brain when you have schizophrenia. So, there's already some sort of link there. And we know that it plays a critical role, dopamine, in motivation and reward processing. But in schizophrenia, excess dopamine activity contributes to hallucinations and delusions. Chronic smoking has also been linked to cognitive decline, suggesting that nicotine may not just be affecting symptoms, but actually worsening brain function overall. So my methods and materials, I had some scans from 81 participants, and there were 4 treatment groups, and they were observed through fMRI scans as shown on the slide. There were 25 healthy non-smokers, 21 healthy smokers, 12 schizophrenic non-smokers, and 23 schizophrenic smokers. So I obtained my fMRI data from openneuro.org, which is a public neuroimaging database. So people can just publish any brain scans that they have without just like having a research paper, and we can just kind of get the scans, and then I can pick them and analyze which ones are interesting to me. So I was able to get my data from there since I don't have access to a whole brain scanning facility. The primary focus was the dorsolateral prefrontal cortex, or as I'm going to be calling it, the DLPFC, which plays a crucial role in cognition and is strongly associated with schizophrenia. To analyze the data, I used 2 key software tools, which were CBrain from McGill University and then FSL from Oxford. And these were used to measure connectivity density or connectivity over time. And FSL helped me detect any structural brain abnormalities so that I can differentiate the schizophrenia versus the healthy smokers. Through this approach, I was able to compare connectivity across all 4 groups and assess the impact of smoking on schizophrenia development, having each variable isolated. So going results overview, the healthy controls had the highest brain connectivity, which makes a lot of sense since they wouldn't be smoking and they don't have schizophrenia. The smokers that don't have schizophrenia already showed reduced connectivity, which means that there is some sort of link between cognitive decline and smoking. But what's even more interesting is that schizophrenic non-smokers had significantly lower connectivity than healthy individuals, but schizophrenic smokers had the worst connectivity and had almost no high density regions in fMRI scans. And the next slide will show images, so this will be a lot more clear. So here are the key findings from my healthy control. You can kind of see that and these are all at rest, and you can see that there's not a lot of bright spots, which means that it's normal at rest without high levels of dopamine. It's not increased because of smoking or because of schizophrenia. And these top scans are going to be showing dopamine, and these bottom scans are showing connectivity. So you will be able to see that there's high levels of neuronal connectivity at the bottom. You can kind of see these like orange and red, yellow spots. It kind of shows that it's there. And then at the top, you can see that it's not a lot of dopamine, but I can see like the dark blue, which is kind of small areas. And then if you go to the next slide, we can see that these are the healthy smokers. You can see a small difference, but you'll see a huge difference when you look at the other two, promise. But here you can see that there's a huge difference. It's like completely blue almost. And then there's no red or like barely any red, barely any orange, which shows that there's a lack of dense connectivity. There's no red, but there's still some oranges and yellows, but it's a lot weaker. And then here you can see that the excess dopamine from the schizophrenia. And then the last slide, the colors are way brighter, and you can see that there's noticeably higher levels of dopamine due to smoking and schizophrenic activity. You can see it's a lot there, it's a lot at the bottom, and just throughout the brain, it's kind of scattered. And then down here, you can see that there's minimal neuronal connectivity. There's barely any yellow, there's no red, no orange. So we can really see that there is a connection. You can see the correlation as we go through the control groups. So just as a summary, these fMRI scans provide visual confirmation of my findings. The red and orange areas indicated high neuronal connectivity, and as you saw, healthy individuals showed really, really dense connectivity, but it declines in smokers and schizophrenics. The most alarming result is the near total absence of connectivity in the schizophrenic smokers that reinforces my hypothesis that smoking worsens schizophrenia-related brain dysfunction. So going off some data analysis, after doing chi-square testing, I got a p-value of 0.03, which is less than the significance level of 0.5, meaning that all of this data is statistically significant. And just generally, as a conclusive statement, we've found that smoking itself reduces connectivity and schizophrenia compounds the effect. So it's not necessarily that smoking itself will cause schizophrenia, but it does show that, let's say you're genetically already prone to having schizophrenia. If you're smoking, that means that you're more likely to develop it. And then just as I'm supporting, oh, sorry, it's okay. Can you go back one slide, please? Yeah, and then just as talking about my data and supporting my hypothesis, we know that nicotine disrupts neural networks, which is linked to cognitive decline. Next slide, please. Yeah, so for conclusions and more, our key takeaway was that smoking decreases brain connectivity, especially in schizophrenics or if someone is schizophrenia prone. And nicotine may accelerate schizophrenia onset at-risk individuals. So we don't know the difference necessarily between whether it's cigarette smoking or just like e-vapes. So another limitation or future research that you could use was not only using other stimulants, but increasing sample size and maybe differentiating different forms of nicotine and seeing how they affect the brain. And then lastly, with limitations, some limitations with the sample data was that there were more males in the sample size. So there might be a difference between how females react and males react, and that wasn't really like accounted for. There was a lot of age variability between the participants. They aged from age 20 to like 60. So there could be a lot of variability with age and like how much they've been smoking. And then there was also relatively small sample size. It was only 81 individuals. So we don't know if that applies to everyone. And yeah, thank you so much to my mentor, Samira, and all the people who contributed the data in Open Neuro. It was really, really helpful. And it has allowed me to expand my understanding of clinical neuroscience and a lot of computational techniques. Yeah, thank you. I'm open for questions.
All right, thank you, Riya. Let me check for any questions here. Okay, I mean, I have a couple. What was this the topic that you originally signed on for, or did the topic evolve once you met with your mentor?
Yeah, so actually, my original topic, I really wanted to look at specifically like how schizophrenia and smoking impacts women, but I couldn't really find any data on women specifically. And since it's so hard to get data myself, I can't just go out and have like people sign up and get data scans from them. So I kind of had to adapt to what Open Neuro had and what data scans that they provided. So I found this, which was kind of similar. So I was like really happy, but it did have to change a little bit due to the data that I was provided.
Gotcha. And so was this data was already available. You didn't conduct the experiment, you
Yeah, I
said.
didn't conduct the experiment, but it was
Gotcha.
analyzed.
And so did you come across anything else in the literature above this 81 person count? Was there any other type of studies like this that you could have seen more data, or was this like the largest available
I
study
think
that?
the largest available, most of it, like when I searched up for literature review, most of what I found was that people have found a relationship between after developing schizophrenia, people smoke, and then that cures like helps their symptoms. But there hasn't been a lot of data looking at whether it actually helps or causes that. So this is kind of
Yeah.
the first study that I came across, or the first data set that I came across that had like looking at that specific connection.
Yeah, I mean, there's so many other questions, and you did a good job at the end of that, where you said, it was maybe overrepresented in male, right? There was age
Right.
variances. But it is totally interesting to think about, how many of them maybe smoked before they got schizophrenia. That's an interesting question, right? Or did they
Mhm.
smoke after? So thinking about causation and then also like correlation to the
Right.
acceleration of the symptoms
Yeah.
is are interesting questions. I enjoyed listening to it. I don't see any more questions in the chat. Let me just double check though. Da, da, da. Let me check. Let me for everyone. Yeah, I think you're good. Thank you so much, Ria. That was great.